module, you will learn about the basics of scalars and vectors. Earlier, you learned about the rectilinear motion of bodies. In simple terms, rectilinear motion is a motion that occurs in a straight line. The motion of a body in a straight line is treated as one-dimensional motion. The description of motion of a body involves its position, displacement, velocity, acceleration, and time. In the one-dimensional or straight-line motion of a body, you are able to represent all these entities on a number line. A number line has an origin, and measurements to the right of the origin are taken as positive and to the left taken as negative. By adopting a proper sign convention for all the entities, you are able to solve the problems analytically. Before you proceed to the next topic that deals with two-dimensional motion of a body, that is, motion in a plane, you need to evolve a new way to represent these entities, as the number line method will not adequately describe and represent them. To fulfill this need, a new way called vector representation is used. Before learning this, you need to learn the basics of scalars and vectors. Let us start with scalars. Entities described completely with the help of a number, along with its unit, are called scalars. The mass of an object is 10 kg. This description is complete, and you do not need to add to it to identify it. Similarly, the distance between point A and point B is 20 centimeter, is a complete description. Likewise, the temperature of a body and the time at which an event takes place are described completely by a number along with corresponding units. A number along with a unit that represents the measure of a physical quantity is called its magnitude. Thus, mass, distance, and temperature are scalars. As with numbers in elementary mathematics, scalars can be added, subtracted, multiplied, and divided. Now let us learn about vectors. Entities that require specification of the line of action or direction in addition to their magnitude to complete their description are called vectors. A vector is always specified by giving its magnitude with the help of a number and its direction. The displacement of the object is 30 centimeter. This statement is incomplete until you add the direction in which the displacement has taken place. The displacement of the object is 30 centimeter in the east direction is a complete statement. Similarly, for velocity and force, you have to specify the direction to complete the description. Therefore, displacement, velocity, acceleration, and force are vectors. Vectors are represented by a straight line with an arrowhead. The length of the line drawn to some suitable scale represents magnitude, and the line itself with the arrow represents direction. Vectors of a given physical quantity can be added only by using the triangle law of addition or the parallelogram law of addition. Let us look at what position vector means. Consider an object moving in a plane. To represent the position of the object, at a particular instant by a vector, you use the rectangular coordinate system. First, choose a point O, which is the origin. Draw the x and y coordinate axes. Represent the path followed by the object on the graph. Then, mark point A on the path, which represents the position of the object at time t. Similarly, mark point A' on the path, which represents the position of the object at time t'. Join O and A with a straight line. Draw an arrowhead at A. Label the line OA as R. Here, OA is the position vector of the object at time t. It is called R. Then, join O and A' with a straight line. Draw an arrowhead at A'. Label the line OA' as R'. Here, OA' is the position vector of the object at time t'. It is called R'. The length of the vector R represents the magnitude, and the direction is from O to A. The length of the vector R' represents the magnitude, and the direction is from O to A'. Let us move on to a displacement vector. Consider the object moving from A to A'. The displacement vector for this motion is obtained as follows. Join the points A and A' with a straight line. Represent an arrowhead at A'. Here, A' is the displacement vector for the motion of the object from point A to A'. The displacement vector is obtained only from the initial and final positions of the object. It is independent of the path followed by the object. Now, let us learn about the equality of vectors. Consider two vectors, P and Q. These vectors are said to be equal only if they have the same magnitude and the same direction. P and Q are two equal vectors. You can prove this by shifting vector Q parallel to itself and overlapping it with P. The equality of these vectors is expressed as P is equal to Q. Consider another case where P' and Q' have the same magnitude, but they are not equal as they are in different directions. When you shift Q' parallel to it and try to overlap it with P', you will not succeed as they are in different directions. You have now reached the end of this module. In this module, you learned that rectilinear motion is motion that occurs in a straight line. Entities that are described completely with the help of a number along with its unit are called scalars. A number along with a unit that represents the measure of a physical quantity is called its magnitude. Mass, distance, temperature, and time are scalars. Entities that require specification of the line of action or direction in addition to their magnitude to complete their description are called vectors. Displacement, velocity, acceleration, and force are vectors.